Hi, I'm Alice, and as always, I'm here to make maths easier for you. Today, we're going to start quite a long series of videos on quadratic equations. So first things first, we're just going to be looking at what actually is a quadratic equation, when are they used in the real world, and when do we use them in our school maths. A massive thank you to my star subscriber, Emily, who asked me to cover quadratics. I hope that this series of videos is helpful to you, Emily, as I'm sure it will also be helpful to a lot of other people. You're a star, Emily. And please like, comment and subscribe so you too can request topics. This is an introduction lesson. So I'm going to be giving you quite a bit of information, and there are no practice exercises today. But if you want to use this lesson for your revision, perhaps you might like to pause and write some notes at any time when you want to, or maybe screenshot some of the key screens to help you with your studying. So we will also, as always, be having a look at a quick psychology tip to help you to learn maths. And here's a list of what we'll be doing in future lessons as well. We will be, across the course of this series of videos, looking at everything you need to know to use quadratic equations in your school maths. It's a UK curriculum-based video, but I'm sure this will be helpful for people all around the world. It will help you today if you already know some algebra basics. So starting with the most basic, that letters represent numbers and that a graph has an X and Y axis and we can plot an equation on there. It also will help you if you know a little about negative numbers, multiplying them, and square numbers, i.e. when you times a number by itself, it makes a square number. If you have some experience of solving linear equations, there's an example there, then that will help you. But I'd say it's not totally essential. If you do want some experience of solving linear equations, I'll put a link to my playlist on that up here. Before we get started on our quadratics, a very quick psychology tip. I think this is a fun one. This is one of my favorites. So, did you know that if you actually put your face in a position which makes it look calm and happy, it will actually cause you to have more calm and happy feelings? It's really true. You should try it. Also, it feels really silly, and I think that helps as well. So you might notice that you tend to store a lot of tension in your face, especially around the forehead, around the eyes, and around the jaw. So you can try, when you notice that you're stressed, just checking in, becoming aware of your face and see if you are tense in those areas. And you could also try giving yourself a little massage up and out in general, across the forehead, across the cheeks, across the line of the jaw, and just putting a happy face on. I know that sounds silly, but just focus for a few seconds on relaxing your forehead, eyes and jaw and putting on a little smile. Honestly, if you start with the happy face, the feelings will follow and you will feel better. And anytime you are feeling you're getting stressed, just have a go at that, a little bit of massage around those tense areas. Okay, let's look at some quadratics. What actually is a quadratic anyway? So this is the most simple one. What we've got, if you look to the left there, is y equals x squared. So the numbers on the y-axis, that's the vertical axis, are the square of the numbers on the horizontal axis. You can see I've also done this in a table here. So we can see that when x is -3, y is 9, because a minus times a minus makes a positive number. So look, there's -3 on the x-axis. And if we go up, look, there is the point 9 on the y-axis. So the reason why it makes this characteristic U shape, which is called a parabola, is because the negative numbers square to make positive numbers. So you can see there, +3, there it is on the x-axis, also squares to make 9. And there we have at 0, 0 squared is just 0. So, and this U shape, or parabola, to give it its lovely fancy name, can also be flipped upside down. I'll show you some of those in a minute. And that's when we times the x squared by a minus number. So all the values flip from positive to negative and vice versa. We sometimes work with the equation, and we sometimes work with a graph, and we sometimes work with both. But it's good to think about it in both ways. It will help you to understand. And somewhere down in the description, you will find a link to this lovely free online quadratic and other equation graphing calculator, which I use to make all of the graphs in this series. You may have seen this before, ax squared plus bx plus c. Sometimes you have that with y equals, sometimes you have that with equals 0. It just depends on what you're doing with your quadratic equation. In general, we use the y equals form when we are drawing a graph, and we use the equals 0 when we are solving the equation. So what are the a, b, and c? A, b, and c are just a way in algebra of saying a number goes here, basically. So for example, you could have 3x squared, and the a would be a 3. Take away 2x, so the b would be -2. Add 4, so c is 4. So a is the number of x squared, b is the number of x's, and c is a number on its own. You actually don't need to have the b and the c to make it into a quadratic. You might have only one of them, or you might have neither of them. The most important thing about a quadratic is the x squared term here. And that's why it's called a quadratic, because quad is a word for square or 4. There it is. Next one. Right, this is what they can look like when they're expanded or factorised. So because we times 2 x's together, that makes the x squared. We can do something called factorising. These are the ones on the left of the factorised versions, where you have split that up into 2 things that you times together to make the full quadratic equation. You see the expanded version on the right. We sometimes need the expanded version, and we sometimes need the factorised version. And over the course of this series of videos, I will be showing you how to work with both and how to change one to the other. So all of these match up with each other, look, and you can see that they all look a bit different from each other, but they all have a squared term in them. So the first 2, we have multiplied 2 sets of numbers and letters in brackets together. And in the second 2, this is actually just the same bracket times by itself. So 2x minus 6 times another 2x minus 6. And in the final example, I've times everything inside the bracket by 7 x's. And as you can see, we haven't got the c number there. You may also notice this one hasn't got the b number. That's something called difference of 2 squares, which we will see in a future video. And here are some graphs of what those could look like. So we can see that we have our basic parabola, but it's not that nice symmetrical shape around the 0, because the a, b, and c terms will move that. So here's one of those upside down ones you can see. Then that's -3 is a, +2 is b, and 8 is c. And we have a curve that looks like that. And then we have our U-shaped parabola there with another quadratic. So we also have places where it crosses the x-axis. There it is on that one. And there it is on that one. These are called the roots of the equation, and they are the value where y equals 0, because if you think about it, across this whole axis, the y value is 0. If you had a coordinate on that axis, for example, it could be like 1, 0 or 5, 0. The whole x-axis has a value of y equals 0. And that's very important in our quadratics, as you will see as we go along with this series of videos. So quadratics can seem very abstract and not very useful to you. You probably don't really use them in your everyday life if you are a teenager or even an adult, but they do have many uses in science and engineering and industry. For example, movement of projectiles, that means anything that is thrown or dropped. The movement of a rocket or a ball that you throw, you may notice that the parabola looks kind of like the shape of something that's thrown. They can be used to calculate the speed and position of things that are thrown or dropped or launched in the case of a rocket. They are very useful if you are manufacturing or engineering and a parabola shape is involved. That U shape is a very useful shape, and being able to map it and measure it can be helped with a quadratic. Also, they can help in a particular way with working out the sales and profits if you are selling something. If you want more details of that and all of the other things that I've mentioned on this page, then I will put a link in the description with a bit more information if this particular thing is interesting to you. Another manufacturing and engineering job of quadratics is when you are making something which is a rectangle shape and you want to know how long to make the sides to get a particular area. Again, more details of that in a link in the description. And they are also useful when you are calculating speed in various different situations, for example, against air resistance or a boat going upstream against a current. There are simply hundreds of uses of quadratics in real life across many different industries. And as I said, there will be a link in the description for more of that. Now, I just wanted to show you how we solve quadratics by factorising. I'm doing a whole video on that, I think about 2 videos from now. And so I won't be spending loads of time on it today. But here is just quickly what that looks like. So we start with our quadratic. There it is, x squared minus 1x minus 2. And I was able to change it into this form, where I found that to make this equation, I can times x minus 2 by x plus 1. I've put equals 0 here because I want to find out what the value of x is when y is 0. Remember that on this whole x-axis, y is 0. Now, why would we want to know that? Well, there's a lot of different reasons why we would want to know that. In the examples that I showed you on the previous page, if you were throwing something, you might want to know when it hits the ground. That would be an example of that. If you are looking for a solution to the problem with the rectangle, then again, that's the answer. That's you've solved the equation. There's quite a few different reasons, and we'll come to that in a future video. So anyway, we have x minus 2 times x plus 1 equals 0. And what's happened is that if I've multiplied 2 things together and the answer is 0, one of those things, at least one of those things, must have been 0, because how can you make 0 by multiplying? There's only one way. It's timesing a number by 0. So logically, either x minus 2 equals 0, meaning that x would be 2, or x plus 1 equals 0, meaning that x must be minus 1, because minus 1 add 1 equals 0. So quadratics have 2 different solutions. When there is a root of the quadratic to be found, the only exception to there being two of them is when it is a bracket or a single x which is just squared. And the reason for that, let me show you. So if you had x squared, then when we put x squared equals 0, we would just have x equals 0. We're timesing two of the same things together, giving us only one result. So as we saw in the previous slide, the graph of y equals x squared just touches the axis there. The other time when it happens is anything else times by itself. For example, if you had this double bracket, x minus 2 squared, that would give you x minus 2 squared equals 0, which means x minus 2 equals 0, and x is 2. What would that look like on the graph? That would meet the x-axis here. So the curve would look something like this. Look, it's, sorry, not a very good drawing of a curve, but it just touches the axis in one place. It doesn't cross the axis. Apart from that, as I said, if you can solve it, there are two solutions. And there are some quadratics which don't have solutions. For example, let me just sketch one here. If you had a quadratic curve here, you can see it doesn't touch the x-axis, and that would be a quadratic equation we can't solve. Anyway, what about when you can't factorise them? You can still solve them using the quadratic formula. This looks a bit intimidating, but I promise you, by the time you have learned everything else you need to know to get there, it's really fine. It's just practice, and it's just another way of solving it. We need the quadratic formula when we can't factorise it because we can't put it into x plus or minus a whole number and another x plus or minus a whole number. So the answer, the roots of the quadratic equation would be decimal or fraction numbers. And here is a list of various, I don't even know if I managed to find all of them, all of the different times when you might need to use a quadratic equation within the UK GCSE maths curriculum. I've split them up by grades. So you can see they go all the way from the highest, grade 9, down to grade 5, including the foundation GCSE paper, actually. I'd say it's sort of the top end of the foundation GCSE paper, but you still can get quite a few marks by knowing them. I'm not going to go into a lot of detail here on this now, but if you want to screenshot this, perhaps you could use it as a revision list. It's mainly just out of interest to just show you how important it is to know this very key mathematical method. Different teachers or different exam boards might place different numbers on these, so it's just for guidance. And also it depends on the level of difficulty of the problem you're solving. It's just an approximate sort of guidance for you there. Always do check your revision list and exam information with your school or exam board, not a YouTuber. And that's it. That's our introduction to quadratic equations. I just really wanted you to know what they are and a little bit about how they work before we start doing all of our mathematical methods with them, because I think it helps to really understand what you're doing, not to just be copying a method from someone. So next up will be expanding double brackets, where we take the factorised form with 2 brackets and we multiply them to turn it into the non-factorised form. And then we will also be looking at how to do the opposite. So taking the expanded form, putting it into brackets. And we'll also be looking at how to draw a graph of a quadratic equation using a table of values. And then we'll be going on to factorising and solving them. Harder version. I've put hard because people always call it that, but I'm sure if you stick with me, you won't find it that hard. And I just wanted to say thank you so much for joining me today. And well done you for putting in the effort to improve your maths and to get a better understanding of it. We will find in the description information on quadratics in real life, that lovely graph drawing tool that I've been using. And as always, mental health support links for the UK and across the world. Please don't suffer in silence. People want to help you. And of course, please like and comment and subscribe. It's a new YouTube channel and I really want to get this teaching out there and help as many people as possible to overcome their maths anxiety and learn important mathematical methods. So any engagement, much appreciated. Thanks very much. Bye.